Hello, my name is Dan Brock. I'm a partner at the Fasken law firm. I'm coming to you by live stream today from, well, the Fasken satellite office here in my children's bedroom in Toronto. I'll be your host and moderator and possibly your disruptor for this webinar today. This webinar is part of the Fasken Global Mining Group webinar series that's been taking place this fall. Our topic today is hydrogen in the mining sector. First, some housekeeping matters, and this is from management, so it's important. There's a chat window on the right side of the screen or below if you're using your mobile device. We want to encourage you to submit your questions to our panel during the discussion by clicking on the questions tab, and we'll do our best to get to them and answer as many as we can. It's also greatly appreciated if you can take a moment at the end of the discussion to fill out our webinar survey by clicking the survey link at the bottom of the screen. Your feedback is very important and much appreciated. Let me also start with some minor disclaimers. I'm not an engineer, but I'm smart enough to have brought along several knowledgeable, expert hydrogen engineers for the discussion today. I'm not an expert in the relationship between mining operations and remote Indigenous communities either, but I'll be joined today by someone who has and lives a deep understanding of these realities and the role hydrogen energy might play in the future of these relationships. For my part, I've come by my interest and understanding of hydrogen energy in the way most lawyers become informed on new and important developments in the marketplace from my clients. And over the past 5 years or so, the number of clients who have developed or in some cases rekindled their interest in hydrogen energy has been steadily increasing. I think this is likely explained by a combination of things: the push to achieve net zero by 2050, the increasing interest and pressure from the investment community for companies to have sustainable strategies for decarbonization, and an increasing set of law and policy initiatives from governments, some carrots and some sticks. But the specific interest in hydrogen energy, especially in the Canadian context, has been driven by two other factors: a transition to hydrogen energy as a potential lifeline for Canada's carbon-intensive energy sector, especially in Alberta, and the almost limitless potential that Canada has to produce clean hydrogen, both green and blue, for domestic consumption, and importantly, to be a major supplier of clean hydrogen to the world, including our neighbors directly to the south. For Alberta, hydrogen energy might be seen as the lesser evil in the electrification of all things, because hydrogen energy is actually a pathway to electrification in transportation, in materials handling, and in industrial processes. For Quebec, Ontario, British Columbia, and other provinces rich in renewable or zero-emission power generation, the production of clean hydrogen presents, I believe, an historic opportunity for sustained and sustainable development. As such, hydrogen might be thought of as Canada's national unity resource of the future, where the global transition to clean energy brings Canada closer together as a nation and affords a unique opportunity for the inclusion of and reconciliation with Indigenous peoples and communities. My hydrogen journey started with a phone call from the CEO of Hyundai Canada, Don Romano, several years ago. Hyundai wanted to bring their new zero-emission fuel cell vehicles into Canada. Don had one problem: there was going to be no place to refuel them. Now, many years later, the same challenge persists for the adoption of hydrogen energy, the so-called chicken and egg dilemma. How can you use zero-emission hydrogen technology when there's nowhere easily to get hydrogen? And who's going to develop hydrogen production and hydrogen distribution systems when there are no customers to sell hydrogen energy to? And when you add the relatively high cost of producing and delivering clean hydrogen today, the challenges are not going away quickly. These same challenges exist for hydrogen use in mining. The mining sector, like all sectors of the economy, is facing increasing pressure to decarbonize their operations from local communities, from investors, and from governments. As we will discuss in more detail today, hydrogen energy presents an intriguing pathway for reducing and potentially eliminating GHG emissions from mining operations. But we're at the very early stages of this pathway, and the road ahead is not short. We'll explore today the challenges and opportunities hydrogen energy presents as a pathway for meaningful decarbonization in the extractive sector. We'll also consider what these challenges and opportunities mean for remote and Indigenous communities that cohabit with mining operations, especially in Canada. But to get started, it's important for get some perspective and to separate out the hydrogen hype from the realities on the ground, to level set, if you will. And for this, I'm joined by Bob Oliver. Bob is the CEO of H2Go Canada and formerly the head of pollution Pollution Probe, an environmental NGO here in Toronto. Hi, Bob. Good to see you.
Good to see you too.
Bob, you're responsible in part for my becoming sort of keenly interested in hydrogen. Your background and experience really kind of informed my you and I discussed early on when I got that call from Hyundai Canada. I turned to you and we began our collaboration then. Mm-hmm. Where does your personal story start with in hydrogen energy? How did you come to become interested in it?
Well, of course, I knew about hydrogen back in the late 90s and early 2000s. There was a lot of talk on the general media. Every night in the news, there was another story about Ballard and hydrogenics and how hydrogen was the wave of the future. Jeffrey Rubin had published a book on the hydrogen economy, and we were all very excited about the prospect of hydrogen. The technology seemed to be coming along, and it was a new era. So I was aware, but I wasn't involved. In 2004, I joined Pollution Probe, and by that point, the hydrogen hype had crested and was diminishing at that point. And it wasn't really looking like it was going to fulfill the promise. And so what I was working on at Pollution Probe was decarbonizing and reducing emissions from transportation energy use in Canada. And so our focus was on renewable fuels, lower carbon fuels like natural gas, and just general powertrain efficiency improvements. How do you achieve the service of transportation with as little energy input as possible and thus reduce the emissions? And it wasn't until my last year of Pollution Probe, 2015, as I was organizing a transportation decarbonization conference. It was a symposium basically. And we basically wanted to explore all of the dominant pathways through which you could achieve credibly progress or achieve zero carbon intensity in transportation. So what are the fuel and powertrain alternatives that would get you there? And we had a lineup of expert speakers. And I was speaking to a corporate fellow from the Department of Energy by the name of David Green. And he was an economist. He informed a lot of my thinking around the positive economics around efficiency improvements. I didn't know he had an interest in hydrogen, but he reviewed the agenda, and I proposed a few things for him to speak on. And he said, "Well, you're missing hydrogen." And I said, "Well, hydrogen, what are you talking about? That's yesterday's news." And he said, "Oh no, the DOE has put millions of dollars over the past decade into achieving performance targets, cost targets on fuel cell technology and hydrogen production technology. And they've achieved all of them with the exception of, I think it was hydrogen storage. They couldn't quite meet their cost targets on high pressure cylinders, but that was just a matter of time it was going to happen." And then he told me that he was working on a study that had yet to be produced, but it basically said that it was looking at decarbonization of light duty vehicle transportation energy use in the US. And he said what their analysis had shown was that there was no pathway to zero that didn't include hydrogen and fuel cells. And I thought, well, that's really interesting. So we brought hydrogen forward into the conference agenda, and it landed in the proceedings. And that's where I really began to understand that, it was time to reconnect with hydrogen and start exploring its opportunities.
Yeah. And since that time, and obviously increasingly more recently, we've kind of, the hydrogen hype, I'll say, is kind of returned. A lot of people are talking about hydrogen. We're having a conference today on hydrogen and mining. There are announcements every day from different companies and different sectors with plans to do things with hydrogen. I think there's a bit of a gap between what people are saying they're going to do and their plans in the future and what's actually getting done on the ground. But there's no doubt about it that people are talking about it today. What's different today than, say, 20 years ago when Ballard was the darling of the stock market and we all thought we were on the precipice of a hydrogen revolution, a hydrogen economy, if you will. And why? There are skeptics out there who say, we've seen this before. Hydrogen will forever be the energy of the future. Yeah. What's different today, do you think?
Well, the big thing that's different from a contextual perspective, the landscape is climate change. The marginal cost of emitting carbon into the atmosphere is rising exponentially. So we need carbon-free sources of energy. And that brings us back to hydrogen. That's one thing. The other thing is the technical and the economic performance of the technology. Probably wasn't really ready in 2000 for prime time. But now we've got 10,000 fuel cell electric vehicles driving around North America, most of them in California, where you have 40 hydrogen
but there's
retail
there's one in Toronto.
There is. There's one in Toronto. Yeah.
That you are driving, courtesy of Hyundai Canada, by the way, at H2Go. There's a car, that's the only, the Nexo, the only hydrogen fuel cell car we're aware of that's on the road in Toronto today. Sorry, little plug for Hyundai.
Yeah. So on the West Coast in BC and in California and a few, as you point out, there's a few dotted spots here and there and one in Toronto where you can get refueling, and where you can get refueling, people are enjoying these fuel cell electric vehicles. Probably more importantly than that, there's got to be upwards of 30,000, maybe approaching 40,000 hydrogen fuel cell powered forklifts operating in warehouse and materials handling logistics centers across North America. And these are hosted by the likes of Walmart, Canadian Tire, right here in Bolton. We've got one. We had a fleet of fuel cell powered forklifts in Toronto as well. So that was absent any carrot, any stick. It was just internal economic analysis that showed this was a great application. And I think one of the most important things that's brought hydrogen back to the fore is that experience, and that everyone wanted to put a fuel cell in a Ford. Everyone wanted to put a fuel cell in a car. That was the path to scale, and scale was the path to affordability. But what we actually discovered is that there were many cost-effective applications of the technology, and they actually found traction in things like materials handling. So you want to start with the technology where it makes good economic sense, and then achieve scale through growth organically from those points.
What are the properties of hydrogen? And you and I have had this discussion before, but I think your view on this is important. What are the properties of hydrogen that make it so attractive as a pathway for decarbonization generally?
It's a carbon-free molecule. So just like natural gas or oil, diesel, gasoline, it's a molecule, which means we can store it indefinitely. We can produce it, accumulate it, move it. It's not like electricity, where you have to use it as soon as you produce it and move it, instantaneously over a transmission grid. You can accumulate it in one place, store it, move it to another place, and then use it. So its molecular properties are very important. The other thing is, unlike natural gas or any oil-derived products, there's no carbon in it. And that's important because this carbon-free molecule can be used in a fuel cell to generate electricity, just like a power generator, either on board a vehicle or in a stationary or portable application. And that's in itself is very versatile. But hydrogen, like a gas, can also be combusted. So like propane, like natural gas, we can burn it for heat. And again, because there's no carbon in the molecule, there's no carbon dioxide emission. The only emission from combusting hydrogen is water. And the way we produce hydrogen, again, hydrogen, most abundant element in the universe. We hear this all the time. 60% of the universal mass is hydrogen. It's all around us. It's in water. It's in all kinds of chemical compounds. All we need is the energy to disassociate the hydrogen from its bond. And then we have, H2, which we can work with. And as long as we're applying low carbon or carbon-free energy to that process, either through the electrolysis of water or through other innovative hydrogen production processes, we have basically a molecule that we can use for heat, power, and mobility. Its conversion doesn't contribute anything to climate change, no carbon, no global warming potential emissions. And if we produce it with low carbon energy, then we've got something that is, for all intents and purposes, as close to zero carbon intensity as we're going to get.
But if hydrogen is so abundant, and I'm not disputing the fact, why is it so expensive? Like this is one of the great headwinds that hydrogen energy as part of the clean energy transition is facing, and that is cost.
Yeah,
that little molecule sure is expensive to produce, to capture and store, to move, to dispense, and to use. So why is it so expensive? And is that a deal breaker ultimately? Is this going to be the reason why we don't have a meaningful hydrogen transition?
Well, I would challenge that it's expensive. It's not expensive because hundreds of thousands of tons of this stuff are produced around the world every year and used in industry. So Air Liquide, Air Products, industrial gas producers everywhere produce huge amounts of this, pipeline it to users. And the users, however, don't regard hydrogen as clean energy. It's not used as a fuel. It's used as a working material for a manufacturing process. They're either manufacturing fuels, they're manufacturing chemicals, they're manufacturing hard products, glass, for example, and all of these require hydrogen, and that's been going on for decades. So clearly the economics are not against hydrogen in those applications. I think what happens is we try to tap into those established material supply chains, and we try to take off a stream of hydrogen in a small package and use it for a fuel cell electric vehicle. And when we do that, we end up accumulating a lot of cost. And it seems apparent to us, well, wait a sec, look how costly this hydrogen. I think, we have a story of a colleague who tried to buy 1 kilogram of hydrogen for a little small project, and it ended up costing hundreds of dollars for that 1 kilogram. But that's because it went through several middlemen, various levels of merchant acquisition and distribution, and it acquired a whole bunch of cost. But that's not the way it needs to be. Hydrogen, as you say, is abundant. It's going to cost more necessarily than the energy used to produce it, but there's all kinds of opportunities to acquire that hydrogen at reasonable cost and move it to the market such that it's economically viable. What I will say, though, again, is that I don't know, I wouldn't make the prediction that hydrogen will ever be as cheap as gasoline or diesel. Some people make that prediction. I don't think we need to, because the cost of those commodities is going to become prohibitive. The cost of climate change, after all, is terminal for the economy. We cannot contribute, we cannot grow our economy and increase the temperature of the planet simultaneously. We have to decouple one from the other. And that is going to come at a cost. But the good news with hydrogen, all our economic analysis, all our experience is that, yeah, it's more expensive, but it's not prohibitively more expensive. It's not an order of magnitude more expensive. It's marginally more expensive. And that's why it's manageable.
When we talk about energy in Canada, I'm sure this is true in most markets, we're really talking about energy stores of molecules or electrons, right? And those two energy stores seem to exist in silos, right? We have our electricity grids, largely publicly owned, that operate in one area of energy use in Canada, and then we have oil and gas and natural gas in pipelines and otherwise operating in another silo. I've often thought that hydrogen is an opportunity to break down the barriers between those two silos and for electrons and molecules to actually function in tandem and to be able to leverage both to actually achieve a new level of scale and opportunity. That's a prelude to the question, what would you say the state is? Clearly, for hydrogen to meaningfully take hold, we're going to need to have new forms of production for hydrogen. What is that a generally understood proposition? And what's the state of that? Globally, I guess, generally, but also in Canada, where are we at in terms of hydrogen, alternative forms, maybe tailored to new markets of hydrogen production in Canada, clean hydrogen production in Canada?
So where hydrogen has been used for decades, and it has normally also been produced. So if you're a warehouse and you have a business case for powering your fleet with hydrogen instead of rechargeable batteries or with propane, you've got a certain set of indoor operating conditions in which a zero emission forklift really makes sense. You go with hydrogen because it's the smart business play. In those cases, they have to incorporate into their business plan the production of clean hydrogen. So where we have experience and concentrations of use, we have concentrations of production. What we don't have and what we haven't broken through yet with is broad-based production. So centralized or distributed production that we feed into some type of distribution system, either transporting hydrogen in some form over the road or through pipeline, or using the electrons that already crisscross the country through the transmission grid and taking them and converting that into hydrogen. We haven't really had a large scale breakthrough with that. And so there's two ways you can go at it. You can say, well, these are, the grids are publicly owned, And as a matter of public policy, we are going to rapidly and massively scale up hydrogen production and make that hydrogen available to any number of end users. The other thing is that, we start small and we grow this market organically. Where we have a good business case for hydrogen, we look at the opportunities to cleverly produce it locally, and we do so. We produce the hydrogen where it makes sense. We keep the cost low. We transport it some distance to an end user, and then we try to aggregate more and more users to that hydrogen network, and we try to bring on more and more sources of supply. So we either approach this with a centralized hub and spoke, or with a distributed production model, or we do a bit of both. In the mining sector, is an interesting area to trial both of these models to see what works.
Let's talk about that for a second. And before I introduce our next panelists, who will get into the more specifics around mining, again, lots of talk about hydrogen as a pathway for decarbonization in the mining sector. Australia seems to be very active in this space. Chile is developing it. We know OEMs are developing technologies, apparently seem to be developing technology, stationary power production to burn hydrogen, or fuel cell applications, large vehicle applications. What do you see as again, hype versus reality? How real is this? If I'm operating a mine, how seriously do I need to take hydrogen as a pathway for decarbonization?
Well, I think you need to take it very seriously. I mean, heavy industry, when confronted with the prospect of bringing the carbon intensity of their operation to zero or near zero, the viable pathways begin to collapse pretty quickly to just a few options. And electrification, you do that wherever you can. You electrify all the end uses you possibly can to get to zero. And those processes that can't be electrified, normally hydrogen can fill in that gap. So we talk about steel making, for example. ArcelorMittal in Germany is demonstrating that they can produce steel with zero carbon intensity. In that instance, what they take is low carbon hydrogen, or hydrogen produced from low carbon sources, and they use it in place of coal to reduce iron ore to iron, which then feeds into the steel making process. So there's a situation where electricity is not going to allow you to extract iron from iron ore from its oxide compound. You need a chemical reaction to do that, and hydrogen offers that reactivity. The result is that you end up emitting water instead of CO2 in the iron refining process, which is part of the upstream steel making process. Then once you're into the steel plant, you can burn hydrogen as a fuel for your blast furnaces, for your basic oxygen furnaces, and you can also supplement with electric arc furnaces. What hydrogen doesn't do for decarbonization, electrolysis or electricity normally complements the process. So, when you talk about, is it real? We've got a lot of demonstration, we've got a lot of experience, but we still haven't got on the ramp to full scale adoption here. That S curve we've yet to ramp up on that. We're still nibbling around the edges here. The exception, again, being a couple of well-developed markets like materials handling. Yeah. And I think light duty vehicles are coming along really strongly now as well.
Okay, well, listen, it's a panel on hydrogen and mining, and I feel like we could use a couple more engineers to kind of really delve into this. So I'm very pleased to add to the discussion that Bob and I are having Al Davidson and Ry Smith. Both are the founders of Change Energy Services, a small engineering company that has a long history, actually, in hydrogen. And a lot of experience in its applications in various industrial settings, including the mining setting. So Al and Ry, thanks for joining.
Good afternoon, Dan and everyone. Thanks for inviting us to this this webinar this afternoon. Much appreciated. So a little bit of background on Change Energy Services. Our roots are in southwestern Ontario, Chatham, to be precise, and we started 30 years ago. And being in Chatham, Union Gas's head office, Union Gas was one of the two major gas utilities in Ontario at the time. They've now been absorbed by Enbridge Gas, and as a result, our early exposure as a consulting firm to Union Gas resulted in us considering natural gas as an alternative energy source in the aspect of its application to transportation. So we have always viewed ourselves as fuel and technology neutral, and in that instance, it's telling the client, are there better alternatives, or should you stick with what you have? And that has resulted in us over the years evolving to where there are four pillars to our business in support of our clients' search for alternative sources of energy, and that's the business case. Does it make sense in the first place? And if the answer is yes, then, well, what do we build for you? So we have developed the ability to design and build alternative infrastructure focused primarily on gaseous uses of hydrogen and natural gas. And when you do that, the third pillar in that exercise is it's got to meet code. So we've developed expertise in standards, codes, regulations to support the idea of building something that's acceptable. But beyond that, safety goes beyond code, standards, and regulations. So we've developed an internal group that applies a risk assessment process to all of the projects that we're associated with. And that's given us now into our fourth decade, and it's the alternative energy space. We've gone through cycles that typically last a decade, and I'll turn it over to Rye to talk about how our decades of exposure have bounced back and forth amongst the various fuels.
And how
Thanks,
you're in
Al.
and you've entered a new hydrogen decade, as I understand it.
That's right. Second time around.
Yeah, thanks, Al. Yeah, when Al started up the company that eventually became Change Energy, I was at Union Gas, so we have a very parallel history, because I was in the natural gas vehicles department at Union Gas, which became a division, and I was designing stations and developing codes and standards there, and eventually became the general manager of the division. And during my time there, I started utilizing Al and his company for a lot of the station development work that we did. And we managed, in that role, I managed as general manager of the division, I managed the development, marketing, and operation of a network of about 60 vehicle fueling stations, both public and private, serving over 9,000 vehicles. And as Al mentioned, we really learned a lot about the benefits and problems associated with the introduction of and use of alternative fuels.
Including hydrogen, and your experience with the hydrogen village was exactly around that, correct?
Absolutely. So I left Union Gas and went to work for a company called Stewart Energy, which was the electrolyzer corporation, which eventually got absorbed into Hydrogenics, which is now part of Cummins. And Al and I built a bunch of hydrogen stations during the time that I was at Stewart Energy, and then I ran the Hydrogen Village program for the federal government. So that was the 2000s, as Al said. You know, the various decades. 1990s was natural gas. The 2000s were all about hydrogen. And in that Hydrogen Village program, we deployed about 20 major demonstration projects throughout the Greater Toronto area, including 5 vehicle refueling stations. In that time period, back in 2007, there were 5 vehicle hydrogen fueling stations in the GTA. They were all developmental and experimental and out there for to be picked apart, and we got good use out of them. And then as Al said, back in 2010, everything kind of swung back to natural gas. We've spent the last 10 years, mostly in natural gas. And over that period of time, we've built over 150 natural gas and hydrogen vehicle refueling facilities and other projects.
I want to talk about mining if we can and the applications here. And I want to start with the same for you and Al both. The question I posed to Bob, from your perspective, and maybe short answers to start, because I have a bunch of questions I want to get to, but how attractive a pathway do you think hydrogen is for decarbonization of a mining operation, say in Northern Ontario? Al, you want to take a crack at that?
It's there. The pathway for hydrogen to help is there. It's not going to be easy, but there is the ability to make low carbon intensity hydrogen in the north and apply it to mines. And that's going to be an improvement obviously over what is now a diesel-centric operation, where diesel arrives sometimes by plane in the early days, and it's extremely carbon intensive. The ability to make hydrogen locally will depend on finding that right combination of renewable resources, wind, solar, run of river water, waterfall, grade separation of water, where you can make electricity to then make your hydrogen, likely from water. But it's not going to be an easy process, right?
And right. Yeah. Let me ask you. So on that, because as I understand it, there's sort of two challenges, right? It's going to be where you get your hydrogen from if you're in a mine, and then how are you going to use it? And I wonder if we could just sort of separate out those two. What are the options for a mining operation, especially mining operations in remote areas, maybe on grid, maybe off grid, but in remote areas, for actually getting access to hydrogen?
Yeah, and that's a really good point, because to Al's point, it's difficult, but it's situational. There are going to be places where it will be easy to make hydrogen, and there are going to be mining operations that are very appropriate for the use of hydrogen. And it's finding those mixes and developing it almost on a case-by-case basis to determine what that value proposition is. So once we make the hydrogen, which could be through a combination of green electricity sources, such as Al has outlined, it could also be from waste materials found from the local towns or industries. And if the mining operation is big enough, it could even be with a small-scale nuclear reactor as that technology develops and comes more to the fore. But yeah, I mean, the uses, how we produce it, but the way we can use it is as backup power, as for heat. We can use it for site power, either, as I said, primary or a backup, or a way to store power on site in a way that is very fungible. You can move it around, you can store it over time. It can be used in vehicles. It can be used for portable power on the mine site. It can be used in a wide range of
can it be used? Can it be used safely underground? Is that an opportunity for technologies based on hydrogen?
There are pros and cons to the use of hydrogen underground. For one thing, you get rid of exhaust fumes, so it can be, it's a huge benefit underground from that perspective. On the other hand, a release of hydrogen is it's a flammable gas, and it poses the same types of risks and hazards that you would have with any fuel that is spilled in the underground environment. So as we've found in the development of code standards and safety regulations, it's all a matter of understanding what the properties of the fuel are that you're working with, because all fuels are dangerous, but understanding those properties and then designing the system around them. So right now, I would approach underground applications with a bit more caution than surface applications, but it can certainly be solutions for underground use of hydrogen can certainly be engineered.
Okay. I wanted to go ahead, Al. Go ahead.
I'm a little more reticent perhaps than Rye on that one. I think a proper risk assessment that the measures you would have to put in place to make it safe to take bottles of hydrogen underground, I think you would be better to, ultimately it will show that make electrons at the surface and move the electrons underground to operate electrically powered machinery. I think that would...
By cable.
I think that would be the... Certainly, that would be my starting point to think about it.
Where is the expertise going to come from? I mean, you guys have expertise, and there are lots of engineering firms out there, but people are just now scratching the surface on hydrogen, how it's used, the challenges associated with it, safety issues. You mentioned codes and standards. I mean, regulators are just at the beginning of figuring out what to do if hydrogen were to become, an abundant and widely used energy in our society. So where does this expertise come from? What's your sense?
Well, there needs to be a serious effort to bring our academic institutions into play here to get new technicians trained in hydrogen, engineers with more direct hands-on experience with hydrogen in the course of their schooling. We know that Canadore College in North Bay is embarking on a program for a hydrogen technicians diplomas, but it's going to take that effort globally, really, in order to meet the need. And then there's all of the technicians now who work with internal combustion engines. There will be a transition where diesel mechanics are going to have to be retrained to work with hydrogen fueled apparatus.
I'm mindful that we have our another panelist, and I do want to bring on Isadore Chief Day soon, and maybe but I did want to ask one last question, get a quick response, maybe from you, Rye. Community relations, indigenous relations, and relations with stakeholders is an important consideration for mining operations, especially in remote areas. Again, does hydrogen have something special potentially to offer in terms of those relationships, and maybe sort of mutually beneficial outcomes for communities in which mining operations function, and for the mines themselves, sort of a symbiotic benefit here?
Yeah, I like that. There is a symbiotic benefit, definitely, because a hydrogen system, by its nature, is not only going to be green, but it's going to be local. And now, when I say green, I mean clean, low emission. A lot of people don't like the color coding, but it's going to be local. It's going to be a local energy system that will be built
microgrids.
And exactly. So there are these things that we refer to as microgrids, because once that energy system is up and running, it becomes a full-on utility. It has water management and possibly, even depending on the system, water production, clean water production. It has heat production as you capture waste heat from the system for space heating. It has electricity production. And that electricity can be used in a number of different ways. And all that infrastructure will be built on site. It can be left as legacy equipment that can then provide that energy system. Now, when you use it in that sort of, when you use all these different forms of benefit from a hydrogen system, you create what you referred to, Dan, as a microgrid of that can actually power and service a town. So whether the hydrogen system is put adjacent to the town, and the services are shipped to the mine or from the mine and brought back to the town. The local the people living locally can manage those facilities on into the future. As Al mentioned, resourcing is a big issue, and we need trained technicians, and so those technicians are just being trained now. And so you have an entire ecosystem around your hydrogen microgrid that is benefiting the community as well as the industry.
Okay. Well, listen, let me take the opportunity now then to introduce our final panelists who, when I made the introduction, you have deep experience in this area, but you also live this reality, Chief Day, in terms of the relationships between mining operations and Indigenous communities. Just by way of quick introduction, Isadore Day, Chief Day, was the former chief of the Serpent River First Nation and a former Ontario regional chief for 15 years, involved in First Nation leadership. He's been the chair of the Assembly of First Nation Chiefs Committee on Health and the establishment of the AFN's Task Force on Cannabis. Chief Day also led negotiations for a successful Ontario First Nation 2.4% stake in Hydro Ontario shares during his time as regional chief. And during his term as chief of Serpent River, Chief Day contributed to drafting Ontario's Green Energy Act. Today, Chief Day is the CEO and founder of Bimaadzwin, a consulting group focused on nationhood and an advocate for First Nation participation in mainstream economy as a means to create long-term community prosperity and employment. Chief Day, thank you very much for joining us today. And I'm going to do what I did, and I'm also going to. I'm looking here. I'm seeing Bob. Bob, you got to chime up as well. If you can't, just let me keep asking questions. So feel free to chime in, and Ryan Al as well, and Isadore. If you want to put back tough questions to Ryan Al, please be my guest. Don't give any tough questions to me, but feel free to pepper them with questions. But by way of starting, the relationship between, say, extractive sector operations, mines, and local communities is, and you've been paying attention recently, more recently in the last months and maybe years even, to electrification, and maybe more recently hydrogen energy as an opportunity for development and growth in First Nations communities. What do you think of the potential relationship, maybe mutually beneficial relationship, between mining operations and remote and Indigenous communities for the adoption of hydrogen? Oh, you're on mute there, Isadore. Words we'll always remember for the rest of our lives.
We should all have a T-shirt as such, right? Okay, thank you so much, Daniel, and to my fellow panelists and those that are watching the session. It's an incredibly hopeful feeling that I have when we're discussing this, even though there's a lot of differing opinions and literacy starting points, if you will, because even though I have a good background in energy policy in Ontario, I think hydrogen is new to a lot of people. And I just want to say, from the perspective of the relationships, I would like to just highlight that more and more across the corporate sectors globally, environmental social governance seems to be the point of reference that we're all speaking about, excuse me, from the context of how are we going to deal with climate change? The issue around climate change for those in the remote north are far more acute and impacting on the daily lives of individuals who can't afford air conditioning, who basically don't have a way out of the community. So the level of poverty that exists in our communities is getting us to focus on these types of solutions in a way that gets us to think a little bit further. Now, let me just start by saying that the relationship issues between Canada's federal family, the federal government, the provinces and territories, municipal governments, unorganized territories, and that of the private sector and Indigenous communities, is far more different than the mainstream. And let me start by saying this. that right now there's a project that is under development. It's called the Wate Power Project from the main transmission juncture down around Sioux Lookout into the far north. There's a societal shift that is happening there, not just access to electricity, but you mentioned earlier that we have a vested interest in Ontario's hydro assets. I think the game changer for the Indigenous communities is going to be when the private sector and industry recognizes that we're unlike the private sector, who does not have access to ownership of Ontario's infrastructure. That hydro transmission line going up to those remote communities is partly owned by the First Nations that will be using it. There's a huge difference in the actual starting point in terms of how the economic models will look. And so I think that the point I want to make, and maybe I'll stop there, is that the relationship that Indigenous communities across Canada are having are based on nationhood versus stakeholder, or versus just an individual First Nation that once had very little to say about development in their territories. First Nations are very much affixed to their territories, have a long history that is even pre-Confederate, pre-contact. And nowadays, governments are recognizing that Indigenous people are going to play a much deeper role in development. So I think when it comes to hydrogen, the same could be said. I think our starting point in the relationship is that of being not just having the rights to that territory, but our responsibility to establish the jurisdictional intelligence around how we work with that, how we make decisions, and furthermore, how the government invests in that scenario is going to have a lot more weight when you sit down across the table with Indigenous negotiations.
I've heard you speak of this before. You mentioned it earlier, sort of environmental, social, and governance issues. And you have an interesting take on it, ESGIR. Why don't you talk a little bit about that?
Sure. And I think I just alluded to the foundational starting point of that, given that I is Indigenous.
Yes.
Indigenous, and I want to just put something to you that you may not understand just yet, but many of the communities would once have said Indian. And Indian meaning the Indian Act. The Indian Act is a piece of legislation that had basically confined Indigenous communities, now called First Nations, to these pieces of land where there was full control by the federal government. Well, that has since changed. Indigenous issues have now become, more the platform for solutions and reconciliation between Crown governments and First Nations, i.e. Indigenous communities, has now advanced in the area of social justice, economic justice, and access to decision making. So when you look at the baseline standards that business and development and relationships are building on, environmental social governance, Indigenous is very much at the front end of this when it comes to what we start to work towards sitting across from the table. But reconciliation, given that in Canada, we know that reconciliation has to do with the impact of residential schools. This basically explained in economic terms is access to the types of economies that will allow us to build a framework of self-sufficiency and participation in Canada's economy. So those are the two additional elements that we will be talking about and doing our work on when it comes to ESG, IR, meaning Indigenous and reconciliation.
Bob, did you have a question you wanted to ask Chief Day in respect of the potential that hydrogen has in the north?
Well, yeah, I mean, Chief Isadore, there's two ways that I've heard hydrogen expressed, the hydrogen opportunity. One is quite simply an off diesel alternative. We switch from diesel to hydrogen and that's it. But the other way I've heard it expressed is there's an opportunity to build out an energy network that could be a creation of Indigenous enterprise, and that, you know, the economic development activities such as mining throughout, you know, the north of Canada would benefit from that. How do you see the is that the end point? Is that the objective, to build out that capacity? And if so, how do you get from one to the other?
I'm going to say that whenever we hunt the moose, it's never the same way every time, and there will be things that we will apply to that activity, how we prepare, the things we do, our protocols and whatnot. But there is always going to be variables that are changing. So in this case here, we know that the pressures of climate change, the economic condition of a post-COVID reality, globally speaking, and where investments are applied. A lot of those things are going to be factors in how Indigenous people decide how they want to participate. And I could give you an example of what I mean by that. When the Ontario government was doing their long-term energy plan, it was the tail end of the Green Energy Economy Act, the FIT 1 and 2, and how they were deploying that last stage of getting the capacity and establishing energy generation. Well, what I decided, and another chief from Oneida, we said, listen, you've got maybe 1 to 2 projects, major 100 megawatt program under the LRT, or under the long-term energy program. We don't think that it's going to suit our community. It's not going to benefit us. So what we did was we developed a policy position, and we asked the Ontario government to support the microgrid program. And when that microgrid program happened, you can only imagine what happened with the communities from the north that were deemed eligible as partners in a solar panel down in downtown Hamilton. Well, this became the catalyst for how northern communities started to look at energy policy, energy investment, and benefit in Ontario's energy sector. So I would like to say that because of the complexities of hydrogen, I think the starting point of hydrogen literacy and recognizing what is going to be involved, you can rest assured that the Indigenous community and those that are involved in the economic policy side, or we've got even Indigenous engineers that understand systems well enough, you know, they're going to come up with a position on Indigenous hydrogen that I think will be of great interest to folks, because I don't think the mainstream understands the capabilities of Indigenous business these days.
Chief Day, I have sort of 2 questions, and the first part is for you, but the second question is for Ryan and Al, if I could. And that is, so again, Bob mentioned one option is Indigenous communities go to hydrogen and they use hydrogen, they get off diesel, and that's the end of it. But the other important one you've been discussing is Indigenous communities, Indigenous businesses owning the means of production, being suppliers of clean energy, being suppliers of hydrogen to local mining communities. I have to think that when you consider the overall cost of a transition to clean technology, you're going to consider, if you're a mining operation, what are the ESG benefits? What are the benefits in terms of my relationship with my stakeholders? Notwithstanding, or maybe in consideration of the challenges of literacy, do you think Indigenous communities are ready and want to get into that part of it? The idea of actually owning energy production and being a supplier of energy, not just to your community, but also to a local extractive operation. And then for Ryan and Al, like, how complicated is that? I mean, is this a level of complexity that means we're 10 and 20 years away from Indigenous ownership of producing green hydrogen, or are these challenges that could be overcome more quickly? First to you, Chief Day.
Yeah, I would first of all, I would happily forgive you for possibly assuming through your question that capacity doesn't exist. And what I mean by that, and
Yep,
I know it's totally
that's
innocent,
fine.
that we do have access to the expertise. The expertise is there, and what I mean by that is we have access to change energy. We establish innovative models, partnerships. We have access to capital, and I think it's a really important element to recognize what is the regional development interest and access framework. And what I mean by that is if you've got access to the travel routes out of Canada to produce hydrogen, and recognizing that hydrogen and exporting to other jurisdictions is going to be one part of the economic framework in Canada. Canada is an exporter country. We have the ability to establish bilaterals with other countries because we have a decision and a say over what happens in our territories. So I think we really do need to set the stage for targeted dialogue as to how this shapes out. And it shouldn't be conflicts on resource development. We need to think those things through and recognize that Indigenous people at the front end of a process, it will mean success and it will mean economic viability.
Okay, and I didn't mean to suggest, and I don't think you said that I was implying that the expertise is there. The expertise is there. The comment I made earlier was that actually there is kind of a dearth of expertise generally when it comes to hydrogen. It hasn't been an energy that has been the focal point of the development of expertise generally within Indigenous communities or outside of Indigenous communities. So there's going to be a learning curve for communities, remote, Indigenous, otherwise, in this, getting used to this, getting comfortable with it. And that led to the sort of the technical question. What is the level of complexity of essentially creating a hydrogen economy, even if on a micro level in a community? And that could actually export energy. Go ahead, Chief Day.
So let me add by saying this. I currently live in the Robinson-Huron Treaty Territory, which is on the north shore of Lake Huron. I live just 30 kilometers south of Elliott Lake, Ontario, which was once the uranium capital of the world. If I was the chief back then, and I know what I know now, we would be doing hydrogen in that mine up there, and we would be looking at the end user model and recognizing that there is an obligation within the uranium mining industry to look at value added modeling that will allow, once the boom bust cycle of the extraction process takes place, what is the end use? How can we best mitigate the impact of that part of the mining sequence, and should there be a future for that infrastructure? I would say yes, because right now the mall collapsed in Elliott Lake. Why? Because the short-sighted planning ideology of mining back in the 50s, it doesn't exist today. So definitely we would see some sort of hydrogen build out from this mine just 20 minutes from my home. So that's just an example of the way Indigenous people are thinking about this today.
Yeah. Rye, your thoughts?
Yeah, I guess, the way you had phrased the question earlier got me thinking here. And, hydrogen systems are new, and they're different from hydrogen energy systems, are new and different from, in many ways, from existing energy systems. But they're not fundamentally more complex. They're just different. They're new. They will require new training. This is all well within the reach of well-trained engineers and well-trained technicians. Hydrogen, as Bob mentioned earlier, is ubiquitous throughout the universe, and hydrogen technology has been developed in different locations all over the planet. You see hydrogen deployments in Europe, in Asia, in North America, in South America. It's not owned by any one group, but I think it's very important what we were discussing earlier and what Chief Day has mentioned a number of times, the local aspect of this. You know, the technicians, the systems developers, the learnings are going to emerge from those localities, and then will be able to be spread. So yeah, a good engineer from the local community would be an invaluable asset to the operation and success of a hydrogen energy system. So.
I'm noting that unless I'm misunderstanding how this works, we haven't gotten any questions from any attendees. So I'm going to invite people, if you do have questions, not to be shy and to populate the Q&A section of the panel. And because we're moving sort of close to the end of our discussion, and what I wanted to do here was maybe ask each of you sort of for some final remarks, final comments as we move to wrap up. We have time, so your comments can be as you'd like them to be. And Chief Day, I'm also again, when we were preparing and discussing your appearance, your participation today in the panel, one of the things I think you were focused on is sort of what are the three key messages that are important for sort of to keep in mind in respect of Indigenous interest in energy, Indigenous interest in the hydrogen, the evolution, if you will, of the use of hydrogen in and near your communities. I know you've covered some of this before, but if you could sort of capsulize it into the three key messages, what would you say?
So I'd say that the first one is inclusivity. It will be vital that Indigenous communities understand the proposals, the developments from A to Z, from cradle to grave, because one thing is clear, is that Indigenous people that are generally part of a territory, once development goes in, development's done, developers leave, Indigenous people are still there. So that's for sure. The legacy of land will always be first and foremost paramount to the Indigenous community. So there needs to be inclusivity. The second one being capacity is an issue. And it's often said that while we do have these levels of expertise that are growing, that without the proper capacity timed and sequenced within a development, Indigenous people will lose those opportunities. And we've seen that in many, many cases. So I think the time that we have right now is probably short from, looking at the net zero carbon targets of 2050. But rest assured, we see the importance of ensuring that the capacity issues are addressed. That's going to equate to a level of certainty from developers and investors. So we definitely need to address capacity. And then the last one being that reconciliation and understanding what the history of Indigenous people is and what happened to the land, and the fact that there is a level of a colonized mindset that built the underpinnings of what we now see as Canada's economic framework. Reconciliation does require all Canadians, government and industry to realize that in addressing reconciliation, the economic output is going to be greater than if you don't. So I need to say that the greatest reconciliation endpoint for everybody is so that way we can save the planet for anybody. It doesn't matter what color your skin is or where you come from. Everybody has a responsibility in reconciling with the land and recognizing that we need to do all we can. And it sounds to me like hydrogen is part of that solution to address climate change.
Thanks, Chief Day. Al, Ry, what are your last thoughts? I'm imagining in my head a conversation, a phone call you get from a mine developer saying, "Okay, want to do this mine?" Go ahead, Al.
Yeah, Dan, for me, it was interesting listening to Chief Day comment on the journey from Indigenous or from Indian to Indigenous caused me to reflect that Change Energies been on a journey in these 30 years where I stated earlier that we're fuel and technology neutral. That's not true anymore. We're agnostic in terms of fuels that are on a path to net zero. We're not interested in continuing with the status quo it's now an existential problem. And sitting here, the problems are more acute in the north. I believe that it's happening faster in the north. Most of the mining in Canada is going to be in the north. So all of us here need to be thinking about net zero for the north as fast as we can.
And the atmosphere doesn't care where the reductions come from. Right?
Yeah, I just wanted to add that early on we were talking about the cost of hydrogen and the value proposition, and Chief Days mentioned ESG IR, and we've really got to keep in mind that hydrogen is in that context. It's not just about electricity or traction power. Sure, if you compare it to generating a kilowatt hour of electricity from some diesel, it's going to be more expensive. But as Bob said, not that much more expensive. But it also brings the added values of the zero emission, the value of enabling a microgrid. The value proposition improves as you bring in these other heat capture and uses of the heat. So you maximize efficiency, deriving multi-use, and creating those legacy assets for the local community, working with as customers or for as clients of those assets. And so it really does help to create that broader value that goes way beyond just the production of a kilowatt hour.
Thanks, Rye. Bob, I'm going to give the last word to you. This has been a fascinating discussion. I want to thank everyone for doing it. Selfishly, I enjoy participating in these things. I learn a lot, and it is a long journey on hydrogen. You have to be patient, in part, as you work on and move ahead with these sorts of opportunities. And the people on this call have been thinking about this webinar, have been thinking about these issues for a number of years. So your insights are hugely important. But Bob, I'm wondering what is your level of optimism here? I mean, obviously specifically in the mining sector, but also more generally, where is your sense of what the next 5, 10, and as we head to 2030 and on our way to 2050? What would you like to see happen, and what are your expectations?
Well, again, let's recognize that continuing to emit carbon dioxide and greenhouse gases into the atmosphere is on a path to termination. We can't continue to do that. So, however expensive you might consider the alternatives to diesel and natural gas, they're not as costly as not transitioning. The cost of a liter to burn a liter of diesel is going to get externally more expensive as we go forward in time. So we have to seriously consider our transition options. And we can tap into renewable sources of energy and convert them to electrons, and that solves a big part of our problems. We can also tap into those same renewable sources of energy and turn them into protons, i.e. hydrogen, and that solves a significant remainder of the problem. I see the intersection with Indigenous nationhood as a profound opportunity to begin to build out those seeds of expertise in the Indigenous communities that are often co-located, at least some level of proximity with the mining developments. And so there's an opportunity to link those two centers of potential production and potential demand together to make the economics work better. Then what you see emerging throughout Canada's north are these little dots of hydrogen production of use. And intellectual resources as well. You got hands-on experience. People begin to innovate with it. They begin to discover new things that we can do. And as Rye was forecasting there's all kinds of little things you can do to improve the economics and the efficiency of that. Then what happens when you begin to knit these things together? Maybe you're flying hydrogen by plane from community to community, or maybe there's an opportunity to move it over the road, or there's an opportunity to run it by pipeline. Now you're aggregating more and more. Now it's beginning to look like an underpinning infrastructure for an entirely new economy that just happens to be zero carbon. Now a lot of things become possible that we never imagined before. Now we can get energy to where we need it. And then there becomes the opportunity to actually start exporting it, which we touched on a little bit already. Another major mining jurisdiction aside from Canada is Australia. And Australia has already begun its field trials with taking hydrogen produced in Australia, putting it onto a barge, a tanker, in ammonia form. Well, actually, there's a chemical liquid form that it keeps the hydrogen stable and stored on board the barge in, and they ship it north to Japan, where Japan is a major prospective user of hydrogen. Japan has made the decision that they need an energy commodity that is neutral across all of the energy input fields. They can take anything and turn it to hydrogen. So they're going to build their economy around hydrogen, and that gives them access to any market in the world that has an energy resource, because as I said, most energy resources can be converted into hydrogen at some point. So then you begin to develop, at that point, the sky's the limit. Canada, rooted in its expertise in hydrogen use in mining communities and indigenous communities, can become a supplier to the world, levering fully its low carbon energy output potential. So that's kind of where I see things going. That's visionary. That's you could debate the practicality of it, but you have to be driven by long-term vision to start taking the first steps in the journey. And it is going to be a long haul. But as Rye was saying, we know a lot about this, right? It's not like we've never used hydrogen before. We've just never used it as an energy commodity before. And I would encourage people to think about hydrogen as an energy commodity with a zero carbon signature. And then the question is, well, how do we use it? By the way, there is a question from the group that I'd like to turn to, because I think it may help round out the discussion here, because it's a very fundamental question. We all know about the Hindenburg, right? We all know about the explosivity and the flammability of hydrogen, and that's a question that's always in everyone's minds. So there was a question here about the context for the risk of explosion in the case of accidents, particularly in heavy-duty transport. Heavy-duty transport is currently reliant on diesel. There's a technically feasible opportunity to transition to hydrogen, both as a combustible fuel, but also as in a fuel cell for electric propulsion in over-the-road trucking. But the question is, what happens when those trucks roll over or collide? What happens with the hydrogen there? How is that dealt with? Is there any knowledge around that? I will give one quick anecdote. I was doing research on the safety systems for locomotives running on hydrogen. And we had some experience in liquefied natural gas to draw upon. So I was talking to some of the engineers in Canada who are working on the deployment of liquefied natural gas powered locomotives. And they had also looked at hydrogen. When they reached out to the national fire chiefs, they discovered that the fire chiefs had already been trained on hydrogen systems by Toyota, so that they could train, firefighters and first responders across North America in advance of the deployment of the Toyota Mirai, which is a fuel cell electric vehicle. And they wanted to train the first responders and how do you safely deal with hydrogen in an accident situation. And they said, coming out of the training, that they actually felt safer dealing with hydrogen than they did with gasoline. So it was an interesting anecdote, but I'd like to turn that over to maybe Al or Rye to address more comprehensively, because they have the experience in dealing with gaseous fuels in commercial transport.
Or I'll take a first whack at it. This goes back to my hydrogen village days. I used to get asked this question a lot. And yes, hydrogen is flammable. Yes, it's volatile. Yes, it has all these properties that make it a fuel. I can't imagine a substance that would be useful as a fuel that isn't volatile, that won't burn, that isn't capable of causing an explosion. Think gasoline, think propane, think any diesel, think any of the fuels that we use. The thing that makes hydrogen dangerous to the extent that it is is the lack of familiarity. People aren't accustomed to using it. So engineers have developed systems around the handling, the safe handling and use of hydrogen. And when those codes, standards, and their associated regulations are followed, you have a very safe system. Can hydrogen cause an explosion? Sure. But think about the event of an on-road accident. Bob alluded to a heavy-duty tanker filled with hydrogen rolling over. Well, the amount of energy is in two forms. One is pressure, and one is the chemical energy. The pressure, in an event like that, the hydrogen would, there are systems that would cause the hydrogen to be released, and the pressure would go away. Those cylinders are designed for incidents of that nature, so that if they fail in a safe manner. If you think about a gasoline or diesel tanker having a similar situation, what happens to that product? It leaks, it puddles, it stays in the area, it contaminates the soil, and it stays as a hazardous good. When you have hydrogen and when it's released, it goes out through a valve and it immediately dissipates into the atmosphere. There are ways
and if you have an ignition source, you have a big fire on your hand with gasoline. The same is not necessarily true in the hydrogen condition.
That's quite true. I mean, there are certain circumstances you have to create to cause hydrogen to ignite. Some of them, we've all seen the cases, the demonstrations of how easy it is to ignite hydrogen. It is, but it's also, there are properties about hydrogen that make it very difficult. The fact that it is so much more buoyant than even natural gas. The fact that it has a dissipative property that's so much greater than natural gas. That the fact that the molecule is so small that it leaks through, it's very difficult actually to trap hydrogen. And so there are properties, and if you take advantage of these properties, you can end up engineering a very safe system. Al,
Ryan, I'm mindful, because I miss these things. Chief Day, you've got your hand up. I see a hand in the top corner. Did you want to chime in here?
Yeah, I just before we close here, I'd like to just say that when we think about the one big reason why we don't have hydrogen right now, it's because of the cost. If hydrogen was cheap at the front end of putting the proper infrastructure there, and if there was an end user, so within the supply chain, the economic model that we're trying to fit hydrogen into right now is like a round pin trying to go into a square hole, if that makes any sense. So I think that we have, and this is where Indigenous communities can play a part. If you think about how Indigenous communities are now part owners of government infrastructure, and I'll go back to the transmission line. I'll ask the question: Will standardized and amended models of infrastructure authorities born on the mandate of government, will this have an impact on how quick we can deploy hydrogen solutions in this country? And I just ask you to consider end use economics and recognizing that in the energy supply mix and what the IESO and the systems operators have been dealing with for such a long time, it's always based on one model. Government has a responsibility to retool the energy supply mix, the cycle of transmission, and ensuring that end users have access to this energy that is going to save the planet. So I just want to just add that to the final commentary, because I know we're getting close to the end, and I didn't want to leave that comment out. Thank you.
No, that's fine. That's fine, Chief Day. Absolutely. Did anyone want to comment on what Chief Day just said? Bob, do you have a view on this? The role of regulators and modernization, if you will, of the approach to
Yeah,
energy regulation?
it's always difficult to break from an established system that's normalized and familiar, however broken it might be, and move to something entirely new. That takes a bit of courage. And Chief Day put his finger right on it. It requires leadership, and government can either lead or it can get out of the way and enable, can support leadership where that leadership is taking shape. And I think that as we try to tightly manage and regulate the decarbonization of established systems, we tend to get very narrow in our focus, and we miss the opportunities that something outside of our familiarity, in this case, hydrogen, represents.
Thank you, everyone. I'm just mindful of time, but I'm also mindful that I wasn't good at picking up the question. Bob, you did. Do we have any more questions that we need to address? That I just want to be careful not to miss anything that some of our attendees might have asked, but I'm assuming no. Is that a no? Bob, you had the last question. I don't think so.
You know what, Dan, one thing I would just add on to that last question, because it was about heavy duty transport. Let's think of rail as a heavy duty application. I was involved through Hydrogenics, now Cummins company, in the early deployment of hydrogen fuel cell electric passenger trains in Europe, where passenger service is the main function of the railway network, not the movement of freight as it is here in North America. And it swiftly passed the most stringent and rigorous standards and approvals process that Europe could throw at it. So again, that's just, it goes to the point that it's a question of familiarity, not a question of inherent danger. There is danger, but as long as you manage it with knowledge, you can reduce that risk to something that's acceptable. And that's why hydrogen trains are now running in Europe.
And we did get another question. So, and it's the question that I actually feared, because in preparing for this panel, we had this discussion before, but because I don't know, I know the answer to this question. I am unaware. The question is this: are there any existing mines using or planning on using hydrogen today? I guess globally, and we can talk about Canada. And I'm not aware of any that are actually doing it today, but that's not to say there aren't. It didn't, in the research around this, it didn't come up. And most of what I've seen about hydrogen and its application in mining space is prospective. Do anyone have insights on or knowledge about, and maybe even past uses of hydrogen in mines, but what is the state of this transition today? Does anyone have a view on that? Al, Rye, or Bob, or Chief Day? Again, I'm aware that the equipment's been done before, but I'm not aware of any mine that's currently operating with or on hydrogen.
There's been prototype vehicles in demonstration projects in mines in Canada and around the world for quite a number of years. But let's get real. Like, is there anything that's being deployed into commercial, regular, normalized operation in a mine right now? I'd have to do the research to find out. Would be surprised if there wasn't something in an early stage of deployment. And the reason I say that is Anglo-American, based in South Africa, with its platinum mines, are big proponents of hydrogen fuel cells. And we can recognize there's a self-interest there, because platinum is an element that's used in the construction of fuel cells. So, of course, they want to see hydrogen become a more dominant energy commodity. But there's nothing wrong with that. What I've seen, and I believe it was with Anglo-American, so I'm speculating here, and people can correct me if I'm wrong, is heavy haul open pit mining trucks, such as the ones you see in the oil sands, hauling bitumen to the upgraders. They're electric powered, as I understand it. So there's a diesel engine on board, but it's not directly geared to the drivetrain. The diesel engine is to power a generator, and much like on a locomotive, electricity is then used to power the traction motors that move the truck. So you just take out the diesel engine and you replace it with a fuel cell stack and a battery system, and you can provide all the motive power you want, provided you're supplying it with enough hydrogen. So I've seen some announcements of conversions and early deployments of that type of truck in a mining. That's open pit, that's not underground. It's vehicular, so it's not dedicated mining equipment, but it's a signal, and others may know more than I do about that.
But I'm aware that Caterpillar and Cummins are developing technology to burn hydrogen for stationary power. Are those, Ry or Al, are those for mining applications, or would they have application in a mining setting?
The only information I have is what's been on the internet from Caterpillar, and I think their focus is stationary applications.
Yeah, and to add to that, as Al said, those are large stationary gen sets running on pure hydrogen. Capital cost is lower than that of a fuel cell of the same power output, but the operating cost, at least the fuel cost, is going to be marginally higher because they are less efficient than a fuel cell system, or at least the ones that we've seen so far are, and we haven't seen the data on the efficiency from Caterpillar. So it's difficult to do that head-to-head analysis at this point in time. So that's for stationary power generation. But there are many companies out there that are developing hydrogen internal combustion engines, and there are sort of two streams of that kind of technology. One is where you're blending the hydrogen in with diesel, so you're seriously offsetting the amount of diesel consumed, and hence the amount of carbon dioxide emissions from that. And the other is for automotive purposes, pure hydrogen internal combustion engines. So we've got that as well. I do know that back in the 2000s, there was a company I believe it was in Nevada, that was testing a fuel cell based hydrogen mine locomotive. So work has been done, and
so this is, but it seems to be dominated by, it's green shoots. It's still the early stages of this. If there are mines operating with the hydrogen equipment, it's early stages. We don't have, as we understand it yet, a mine based on a hydrogen energy system, for example. But maybe that's coming.
All of these things build on each other. We did an analysis for a mine operation on hydrogen several years ago, but when we did that, the ESG aspects weren't as highly valued. So that wasn't baked into the equation. The ability to integrate with the local indigenous communities was not baked into the equation at that point in time. So if we redo those analyses, and if companies are looking at ways that they can provide that broader, more holistic value proposition, you're going to see much better value today.
I'm going to have to call it there. I'm just one eye on the clock. I think when we started, we thought maybe we would go for an hour, but we've gone for a full hour and a half. So I wanted to take the opportunity to thank each of you, my panelists, for participating today. Chief Day, Ry, Al, and Bob. It's been a pleasure having you and having this discussion. I also wanted to thank our attendees. We can't see you. You can see us and hear the discussion. We don't get to see you. We're talking amongst ourselves here, but we know you were out there, and we're grateful for you taking the time. We hope you found this interesting and informative, and welcome the opportunity to continue the dialogue in other fora going forward. I also wanted to take a chance just again to remind everyone it would be greatly appreciated if you can take a moment to end at the end of this to fill out the webinar survey by clicking the survey link that's below at the bottom of your screen. Your feedback, as was your participation today, was important and very much appreciated. So on behalf of the Fasken and myself and the panel, I want to thank everybody. Have a terrific day and be safe. Thank you.